রেকর্ডিংটা পরে করব, আমি স্টার্ট করব। Okay, good morning all of you. So we'll continue with the lecture continuity and differentiability also today, and today I will try to finish the chapter on continuity differentiability, especially on differentiability. So today we will do some problem analysis also, some more advanced problem, and the latest question paper problems I will try to solve on that. Continuity and differentiability. Continuity and differentiability. So next, my question number one, today's question number one is, let fx equal to limit n goes to infinity sin x to the power 2n, then which of the following is not true? Option A, discontinuous at infinite number of points. Option B, discontinuous and x equal to pi by 2. C, discontinuous and x equal to minus pi by 2. And option D, none of this. Department, can you see the question?
Yes, sir.
Okay. Okay, to solve this question, you see the limit. The function is given by some limiting of this sin x to the power 2n, n goes to infinity. So whenever there is a n goes to infinity, you have to remember two things, or one very important theoretical knowledge that is required for solving some problems on n goes to infinity. That is, suppose limit n goes to infinity x to the power 2n equal to 0 if mod x less than 1. If modulus of x is less than 1, that means if x lies between -1 and 1, then limit n goes to infinity x to the 2n is 0. And this is going to be 1 if mod x equal to 1. So I will use this theory. The theory is limit n goes to infinity x to the power 2n equal to 0 if mod x less than 1. If mod x, that means if x is a very small value between -n and 1, suppose half to the other power is increasing, 1000, 10,000, 1 lakh, so it will goes to 0. This value goes to 0. Half to the power 1000, the value is much closer to 0. And it is 1 if mod x is 1. So this is a theoretical. So in this problem also, if you write the problem, so I am using this part. This is the additional part to solve this problem. So if I solve this problem, limit n goes to infinity sin x to the power 2n equal to 0 if mod sin x equal to less than 1. Mod sin x is less than 1 and equal to 1 if mod sin x equal to 1. This is true. This is true. So where is the discontinuity? Discontinuity is as 1. Where is the discontinuity? Continuous for all except. So discontinuity at sin x equal to 1. That means x equal to 2k plus 1 into pi by 2. At these points, k belongs to the k is an integer. These points, you see, sin x is 1, where sin x is an x is pi by 2, or 2k plus 1 into pi by 2 for different values of the integers. So this is the point of discontinuity. So what about the options? Tell me which option is correct. Then which of the following is not true? So you go to option A, discontinuous and infinite number of points. That is true. But it said not true. Discontinuous at x equal to pi by 2. True. Discontinuous at x equal to minus pi by 2. True. None of this. It's a very dangerous option. Got it? Ishan, Dipaya?
Yes, sir.
Okay. Next question. Example 2. Discuss the continuity of if x equal to 1 if x belongs to rational number, equal to 0 if x belongs to R minus rational number, that is irrational numbers. So this is 1 if x is a rational number, and this is 0 if x belongs to the irrational number. Okay. Now I'm not giving options for that. I'm just discussing about the continuity. This type of rational irrational part is very important. Okay. Now I'm just giving you one concept of density property of real numbers. Density property of real numbers. So I'm drawing a real line, number line. 0, 1. This is an interval. Now the question is, how many rational numbers between 0 and 1? In fact, how many irrational numbers between 0 and 1? Yes, yes. So suppose between two rational numbers, there always exists an irrational number. Between two rational, if A and B are rational, between two rational numbers, there always exists an irrational number. Also, between two irrational numbers, there exists a rational number. So that means rational and irrational are very close, dense on the number line. Rational and irrational numbers are very dense on the number line. So that is the concept of density property of real numbers. Very close, dense. You cannot separate them. If you take a magnifying glass, you will see they are just like very close. Cannot separate. So that is called the density property. Between two rational, always there is a irrational. Between two irrational, always there is a rational. Okay. Now, this is very important concept for rational irrational. Now suppose if x equal to 1 when x is a rational number, and if x equal to 0 when x is an irrational number. Okay, the question is clear. Now suppose let x equal to a, suppose any number a. Then what is the left hand limit? What is the left hand limit of the function? What is the left hand limit? Let me draw a. So you are approaching from the left hand side, taking very small values, very close to a from the left. So what is the left hand limit? It can be 0 or 1 according as a is rational or irrational. Right? It can be 0 or 1. That means it can be rational or irrational. According as if a is rational, it is 0. 1. And if a is irrational, it will be 0. 1 or 0, you write. Better to write 1 or 0. Okay. What about the right hand limit? What about the right hand limit? Again 1 or 0. You are approaching from right, taking very close to a values. So 1 or 0, according as a is rational or irrational. So what do you see? What do you see? Very fast fluctuation is going on. Like this. If it is rational, it will jump to 1. If it is rational, it will jump to 1. If it is irrational, the next value is irrational, very close, it will come down, again go up, come down, go up, go up. So quick fluctuation, very quick, dense, very dense. You cannot capture the picture of that. You can't. So this is discontinuous, actually. So it's basically fx is oscillates between 0 and 1 for all values of a. For all, I am taking a particular value a. You can take b, you can take any value. It will do the same nature. Am I clear with this concept? Ishan, Dipayan?
So means it will be either at 0 or at 1 consecutively, and the thing cannot be determined.
No, you see, you can't determine the value because it's very close. You are approaching very close to a from the left. It will 0 and 1, 0 1, 0 1, 0 1. On the right, 0 1, 0 1, 0 1, and the values are very close. Density property of real numbers. Rational and irrational. Actually, rational number and irrational number our বাংলায় বলি গিজ গিজ করছে. That is density. So left hand limit, right hand limit does not exist. Next, right, left hand limit, right hand limit doesn't exist. So it is discontinuous at every point. Discontinuous at x equal to a for all a. For all a, all points are discontinuous points. Am I clear? Dipayan, Ishan?
Yes, sir.
Am I clear, everybody? So left hand limit, right hand limit doesn't exist. Next part. Next is question number 3. I will give you the similar question. Discuss the continuity of fx equal to x x belongs to the rational number, and 1 minus x belongs to real irrational number. Real minus rational, that is irrational. If x is, in this case, if x is continuous at x equal to a, where x equal to 1 minus x, that is x equal to half. It is continuous at x equal to half. Now let me explain that part. Acha, what is your f half? Half, because half is a rational number. Okay. Okay. Now, if x tends to half plus, right hand limit I want to check. So if x can be rational, x can be irrational. Correct? Okay. So if half can be half or 1 minus half, that is half in both the cases. Am I clear? So this is the right hand limit. When x is approaching from the right, x can be rational, irrational, as usual as the previous one. So if it is rational, it will take x, that is f half is half, and if it is irrational, it will take 1 minus x. So in that case also it is half. So half is the common point. And if x goes to half minus, then x may be rational, irrational. In that case also, half, half. You see? So if this is plus, this is minus. So fx oscillates between half. So where is the continuity? Half. Half is the continuous point. So half is the common point where the function is continuous. Only point where the function is continuous. Other points it will be oscillates. Other points, if you take other points, it will oscillates. You see, if you take 2, so what is the value? Either 2 or minus 1. So it oscillates. So half is the only value where it is continuous. So it is continuous and x equal to half. Am I clear, everyone? Okay. Next question. A function fx defined as cos x sin x. X is rational, x is irrational. Is continuous at x equal to n5 plus pi by 4. N belongs to the integer. Option B. x equal to n pi plus pi by 8. N is an integer. X equal to n pi plus pi by 6. X equal to n pi plus pi by 3. Yeah, tell me. Yeah, so this function will be continuous at a common point. So when cos x equal to sin x, that means tan x equal to 1. So tan x equal to 1 means tan pi by 4. So it's going to be the general values. N pi plus pi by 4, n belongs to the integer. Set of integers. Okay, so after solving this rational irrational 3 or 4 problems, I hope the rational irrational concept is clear, and it's based on the density property of real numbers. Next, more problems. Let fx equal to minimum of x comma x square, x greater equal to 0, max of 2x comma x square minus 1, x less than 0. Then which of the following is not true? Fx is continuous at x equal to 0. Fx is not differentiable at x equal to 1. Fx is not differentiable at exactly 3 points. D, none of this. Okay. So basically you have to draw the regions actually. Draw the graphs. So let me draw the graph. Let me take the region x greater or equal to 0. You have x and x square. So this is your x. Y equal to x greater or equal to 0. And this is your x square. So this is y equal to x square. This is y equal to x. For x less than 0, you have twice x. So twice x. This is suppose twice x. Okay, this is y equal to x. I'm not drawing this portion. X less than 0. Okay. And y equal to x square minus 1. So x square equal to y minus or minus 1. This is a parabola.
Yes.
This is a parabola. Center parabola vertex is 0 minus 1.
Minus.
0 minus 1 is somewhere here. Okay. And up. Yeah, this is the point. This is the meeting point. There is a corner at this point. So corner at 0. Corner at what about this point? Solve x equal to 1.
1.
This is 0 and this. So you have, you see, you have 3 points of non-differentiability from the graph. Oh, you have to do the minimum of this. Minimum of this. So minimum of this is basically, if I draw the minimum, this is the minimum. This is the lower part. You see, starting from 0, this curve value of x square, then y equal to x. So this is the minimum, and in this case you have to take the maximum. Maximum will be, so let me draw a dotted line here. So this is the maximum portion. Yeah, this is the max of those two graphs, 2x comma x square minus 1, less than 0, less than 0, and less than 0, not equal to, but equal to the right, you have, this is the minimum of x comma x square. Okay, clear? This is the max portion, this is the minimum portion. Now, this is the function, you have drawn the function and everything that we explained from the graph. So we can see 3 points of non-differentiability. One is 0, another one is 1. The curve is continuous. The curve is continuous. You see the graph, nothing to calculate. Nothing to calculate. There is no break. So the graph is continuous. Okay? And non-differentiability is
Not functional at exactly 3.
this point also. What about this point? You have to solve these two values. 2x equal to x square minus 1. This is the quadratic. So if you solve x square minus 2x minus 1 equal to 0. So what are the values of x? Can you tell me? Hurry up, quick. One of the value is root 1 minus root 2, right? So another value is 1 minus root 2. So 3 points of non-differentiability. So which one of the following not true? If x is continuous at x equal to 0, this is true. If x is not differentiable at x equal to 1, true. If x is not differentiable at exactly 3 points, true. None of this.
2 plus minus 2.
All are true. All are true, but it said not true. Not true is none of this. Clear? You have a next question. Fx is given by ax square plus 1, x less than equal to 1, x square plus ax plus b, x greater than is differentiable at x equal to 1, then you have to get the values of a and b. So, differentiability implies continuity, but the converse is not true. Continuity does not ensure differentiability. So, differentiability implies continuity. So, continuity means this is a very important part. Differentiability implies continuity. So, continuity means there is one point only a equal to 1, x equal to 1. So, you have to check left hand limit at left hand limit equal to right hand limit, and that equal to functional value at 1, that is the continuity. So what is your left hand limit? Left hand limit x tends to 1 minus fx equal to limit x tends to 1 plus fx equal to f1, functional value at x equal to 1. So that is equal to, you have a plus 1, this one equal to right hand limit 1 plus a plus b, f1 is same as this one, so I'm not writing. So after simplification, what is the value of b? B equal to, okay, b equal to 0. So you got b equal to 0. That means your option can be either b or c. So I will check the differentiability now. So let me apply differentiability at 1. So for differentiable, it is differentiable at x equal to 1. That means a dash 1, left hand derivative equal to the right hand derivative. They must be equal for the differentiability. So that is equal to limit x tends to 1 minus fx minus f1 over x minus 1, and on the right limit x tends to 1 plus fx minus f1 by over x minus 1. So in this case you have fx can be selected as this one. So ax square plus 1, f1 is a plus 1 over x minus 1, and this side you already have b as 0, so you can plug b as 0. Then it's x square plus ax minus a plus 1 over x minus 1. So x square minus 1 over x minus 1, because 1 get cancelled if you open the bracket. X square minus 1, and if you take a, x minus 1. So what do you have? X minus 1 cancel. Here also x minus 1 cancel. So ultimately you have 2a, right?
2a equal to
if you prove the limits, and equal to a plus 2. So that will give you a equal to 2. So it's option C.
So এইভাবে ছোট করার জন্য একটু ডিফারেন্সিয়েট করে 1
Example 7. The number of points of non-differentiability for fx equal to max is 4, 3, 2, 5. The number of points of non-differentiability. So you can draw the sketch also. Okay, what is your mod x? This is your modulus of x. What is your mod x minus 1? It will go down. This is okay. So mod x minus 1. Now you have modulus of x minus 1. So it will go up, right? Like the blue. So this is your mod x modulus of mod x minus 1. And let's draw y equal to half. Okay, let it be dotted because I have to write max. So this is your 1 point actually. 0, 1. Okay. So this is y equal to half lambda. Now max of these portions. So max will be this bold portion. Let me give it dotted. So you have 1, 2 sharp or corner points, 1, 2, 3, 4, 5. 5 corner points where it is non-differentiable. So option D. Next question, number 8. Let fx equal to sin 2x (0 less than x less than equal to pi by 6) ax plus b 5/6 less than x less than 1. If x and f prime x are continuous, little bit different language you have. If x is continuous, that we know, but if prime is x is also continuous, then option A equal to 1, B equal to 1/√2 plus 5/6. Option B, A equal to 1/√2, B equal to 1/√2. Option C, A equal to 1, B equal to √3/2 minus 5/6. D is none. Yes.
One foot credit or 5/6 foot credit.
Yes. Or if x is continuous,
If it's continuous.
one of the condition
Condition.
that will give you one value. If dash x is continuous, but derivative exists.
মানে left limit that will stand.
Derivative exists করছে,
হ্যাঁ
so সেখান থেকে পেয়ে I'm just writing that part, just at 5/6.
at 5/6.
So left hand limit equal to right hand limit equal to f 5/6. That will give you one of the solution or one of the condition or one of the equation. Another L f dash 5/6 or f dash 5/6 because it is differentiable.
So the J is what it's going to name.
Okay, so your option is C, right? After solving and after getting this result. Nine. E to the power minus 1 by x square, x greater than 0, 0, x less than equal to 0, then if x is differentiable at x equal to 0, b continuous but not differentiable at x equal to 0, discontinuous at x equal to 0, none of this.
Sir, option C.
Now, first question is it continuous or x equal to 0 or not? That is the first question. That will be the first question.
Yes, sir.
Yes, Ishan?
Yes, sir. It will be continuous because for lesser than equals to 0, the value is given to be 0.
Yes, correct. So for continuity, we have to take left hand limit at 0 and right hand limit at 0. You see there is a square. So let us calculate the left hand limit. You can take any negative value close to 0, any negative value. So 1 by x square goes to infinity. 1 by x square goes to infinity and e to the power minus infinity is 0. This is the exponential graph now. So e to the power minus in this side you have minus infinity. So it goes to 0. Exponential function decreases, tends to 0 if it goes to infinity. And a square, if you take negative value, it will be, doesn't affect the negative sign. So it will keep the sign negative always. So it will tends to 0. If you take the right hand limit also, obviously it doesn't change the sign. It will goes to 0. So it is continuous. So let me check the differentiability. You can check left hand, right hand, both. On both the cases, you have the same thing. You can check. Okay, let's check left hand. Okay. So it's 0 by 0 form. Let us apply L'Hopital's. Right. In this way, it will increase the power in the denominator. Let me write in a different form. Wait. I'm not writing here. I will write can I write this? Infinity by infinity form. This is also indeterminate form. Now apply like this. Clear? Okay. It's 0 minus, no problem. So it's 1 by x now. Minus a half x times e to the power minus x. What is the value of this limit? What is the value of this limit? 0. Is that clear? Am I clear? The value of the limit is 0. Similarly, right hand limit also 0. So it is differentiable at x equal to 0. Option A. Okay. Define clear?
Yes, sir.
Let f(x) equal to limit n goes to infinity ln 2 plus x minus x to the power 2n sin x over 1 plus x to the power 2n. Then if is continuous at x equal to 1, limit x tends to 1 plus f(x) equal to ln 3 limit x tends to 1 plus f(x) is equal to minus sin 1 and option D limit x tends to 1 minus f(x) doesn't exist. It's a double limit actually. This n goes to infinity, one of the limit, another limit is x equal to 1. So you have double limits. It's a problem of double limits. Acha, what is your f1? fx is given. So can you calculate f1?
Ln 3 minus n1.
Limit n is not there, n will be not there. Na? Limit n goes to infinity, ln 3 minus sin x over 2.
Silence.
Sin 1, sin 1. Right. Now let's check right hand limit at 1. Let's check right hand limit at 1. Limit x tends to 1 plus fx equal to limit x tends to 1 plus limit x tends to infinity ln 2 plus x. 1 plus is means x is greater than 1. X is greater than 1. That means x is greater than 1, then 1 by x to the power 2n tends to 0 as n tends to infinity, right? And if x is less than 1 or mod x is less than 1, then x to the power 2n tends to 0 as n tends to infinity, right? X is more than 1. If x is more than 1, 1 by x to the power 2n tends to 0 as n goes to infinity. If mod x is less than 1, x to the power 2n tends to 0 as n gets to infinity. Clear? So I will write 1 by x to the power 2n. So that is equal to limit x tends to 1 plus n tends to, we are writing one limit only instead of writing both the limits. ln 2 plus x over 1 plus x to the power 2n minus limit x tends to 1 plus n tends to infinity sin x, this part by this part, right? Me. This is infinite. X is more than 1. So this will be 0. Because the denominator is much larger than the numerator. As n goes to infinity. So this will be 0. Minus. This value will be 0. Because n goes to infinity. Right? If x is more than 1, 1 by x to that point tends to 0 as n goes to infinity. This is 0.
What is the sin x by 1?
So it's sin 1 minus sin 1. You got an option C. And you can check. I think the right hand limit, left hand limit doesn't exist. Okay. This is right hand limit. This is right hand. This is your option C. You can check the left hand limit doesn't exist. Or only option C is correct. This is not multiple option correct.
Only one.
You can check the rest of the part. Okay. Just 2 minutes. Next is if fx equals x to the power a sine 1 over x, again this x to the power a. This is a very common question and very important also. Is continuous, but non-differentiable. At x equal to 0, then minus 1 comma 0, sorry, 0 comma 2, a belongs to D. Yeah. It is continuous. Nothing to check about the continuity. It's continuous. Non-differentiable at x equal to 0. Then what is your option for two?
Sir, option D.
No. Okay, let's take the derivative test. Right hand derivative, let's check for right hand derivative test.
Sir, I guess it will be option C.
C, yes. Very good. So x to the power a minus 1 sine 1 by x. If right hand derivative doesn't exist, suppose, because it's talking about non-differentiability. Then a minus 1 must be less than equal to 0. That is a less than equal to 1. Okay. So I'm not talking about the lower part, but your only option is C that follows here. 1 or less than equal to 1 values. 1 or less than 1. Those values, it is not differentiable. And if it has to differentiable, a minus 1 greater equal to, what should be the a minus 1 greater than 1. Greater equal to 1. So a must be greater equal to 2. Otherwise it is not differentiable. 2 or more than 2. Right, Ishan?
Yes, sir. তাহলে এই x টাকে নিচে নামিয়ে 1/x ফর্মে হয়ে যাবে তাহলে।
Yes. Clear? the number of points where the function fx equal to max of mod 10x cos mod x is non-differentiable. In the interval minus pi and pi is, it is an integer type question. Integer type.
3.
Check very clearly.
Third,
Hmm.
three points.
3. Okay, let me draw.
Sorry, sir, it will be 4.
Acha, mod 10x will be like this. This is your pi by 2 minus pi by 2. This is your pi by 2. This is your origin. This is your pi. Pi is not included. Minus pi. And this is your pi. This is mod 10x within minus pi and pi. Cos mod x. Cos mod x is same as cos x. Because x greater than 0, it will be cos x. X less than 0, negative. Cos will absorb the negative sign. It will be cos x. Cos pi by 2 is 0, right? So what is the maximum part? Maximum part will be this part. I am retracing the path. This path and this path. Right? These are should be dotted.
Yes,
Tell me
sir,
in
you
the
had
chat.
minus pi by 2, minus pi by 4, and pi by 2. 4
What
points.
about this point minus pi by 4, right? What about
Yes,
this point pi by 4? So you have these 4 points.
Yes, sir.
So you have 4. Good question. Because people will answer 2. These 2 pi by 2 minus pi by 2 is itself inside that those are the points of discontinuity also. अच्छा let fx be a quadratic expression which is positive for all real x if gx equal to fx plus f prime x plus f double prime x, then for any real x, which one is correct? Option A, gx less than 0. Option B, gx greater than 0. Option C, gx equal to 0. Option D, gx greater than or equal to 0. Fx is a quadratic expression. So if fx is a quadratic, nothing is given. So if fx is a quadratic expression, let us assume fx as ax square plus bx plus c. Then what is your gx? Okay, fine. Okay. So this is also quadratic. Gx is also quadratic. And fx is which is positive for all x.
Sir, I guess it will be gx greater than equals to 0.
Huh?
Gx greater than equals to 0.
Gx greater than 0.
Oh, sorry, greater than equals to greater than 0 hai.
Yes.
Option B.
Yes. Very good. So it's given a greater than 0.
A will be always greater than 0 and B will be always less than 0.
Less than 0. Discriminant is less than 0. What about the discriminant of G?
Less than 0 it will also be.
2a plus b whole square minus 4a into 2a plus b plus c. You calculate, it will be b square minus 4ac minus 4a square. And this is already negative. This is also negative. So it's less than 0. So d less than 0 means gx greater than 0. A greater than 0, gx greater than 0. So gx greater than 0. Now I will solve some latest question of the paper. WB JEE as well as mains. Question number 14. If fx equal to cos inverse 1 minus fractional part of x whole square sin inverse. We haven't done inverse trigonometry. In the next class we will start inverse trigonometry function. Step by step we are moving. So sin inverse 1 minus fractional part of x not equal to 0, and this is alpha if x equal to 0. This is the latest whole divided by, fractional part of x minus fractional part of x whole square, and this is alpha if x equal to 0. Then find alpha if fx is continuous at x equal to 0, where within the curly braces this is fractional part of x. Your options are pi over 4, pi over root 2, no value of alpha. This is the latest question, 20 or 21. First of all, 0 at x equal to 0. So first of all, you check as limit x tends to 0 plus what will be your fractional part of x, and check the values for limit x tends to 0 minus what is your fractional part of x. X tends to 0 plus what will be your fractional part of x? Limit x tends to 0 plus fractional part of x is actually x minus box x. That is x. Box is 0. So it is x. And what about this one? Zero minus less than 0. So box will be minus 1. So it's gonna be x plus 1. Just calculating the limit. So fractional part will be x plus 1 and fractional part will be x. But whenever it's better to write like this, as x tends to 0 plus, not limit, you are not calculating limit. Then this will, fractional part will be x. As x tends to 0 minus, this will be your x plus 1. Fractional part will be x plus 1. Okay? Clear? So let us calculate the right hand limit. So this will be right hand for right hand limit, this will be x, right? Right? All fractional part will be x, replacing all fractional part by x. Clear? Okay. Now this part is actually 1. Pi by 2, sorry. This part will be pi by 2. See? What about this limit? This is 0, 0 sin inverse 1. Sin inverse 1 is pi by 2. Because sin pi by 2 is 1. This is the inverse function. Principal value I am considering. So it will be pi by 2. Limit x tends to 0 plus cos inverse 1 minus x square over x. Now this is 0 by 0 form. What is the derivative of cos inverse x? Minus 1 over 1 by root over 1 minus x square. Pi by 2. Limit x tends to 0. This is denominator will be 1. This is 0 by 0 form. So minus 1 by root over 1 minus this one, right? And the derivative of this part will be minus 2x. So what is the limit? Minus minus plus. It will be 0, right? No, sorry. You have to expand this. You have to expand the denominator. Can I use this part? Can you see this? Pi by 2, limit x tends to 0, 2x by 1 gone. It will be 2x square minus x to the power 4, right? This 2 cancel. So it's pi by root 2. Check. It's pi by root 2. Please check. Now what about left hand? What about left hand? Cos inverse, your fraction will be 1 minus x, right? 1 plus x. Fraction will be 1 plus x if it is left hand limit. Correct? X plus 1, sorry. So it's 1 minus x plus 1 whole square. Sin inverse 1 minus x minus 1. All fractional parts of x will be replaced by x plus 1. Clear? cos inverse. One cancel. What is the result? Minus 2x minus x square. Okay. Sin inverse x by in the denominator you have minus x into x square plus 3x plus 2. Please check. This was, oh, this is square, huh?
Yes.
This should be cube. I made a mistake here. Okay, you can calculate the rest of the part, okay? That means the previous also, it's a, I made a mistake, it should be cube. So in this case, your value will be left hand limit will be 5 by 4. Please check. You will check at home, all of you.
But the alpha doesn't exist.
Yes, it is not continuous because left hand limit is different from right hand limit. So there is no value of alpha for which it is continuous. That is the question. It's a latest question. I will give you more latest questions.
So I get whether or not the extra common of that. So
Yes, yes.
the even integer the power to the common.
Yeah. Next, latest question. All are latest question. 14 minutes. Let f from R to R be defined as fx equal to x to the power 5 sin 1 by x plus 5x square x less than 0 equal to 0 when x equal to 0 x to the power 5 sin 1 by x lambda x square when x more than 0. The value of lambda for which f double dash 0 exists is, let it be integer type. So it's talking about the second order derivative. That means first order derivative exists. It's talking about the first order, second order derivative. So first order, let us assume first order derivative obviously. If second order derivative exists, whenever first order derivative exists. So let us find out the f dash x. Right? Okay. Right. Okay. So I will take the test. That means what is the left derivative? And So that is x tends to 0 minus f dash x minus f dash 0 over x minus 0 equal to f dash x minus f dash 0 over x minus 0. So that is equal to limit, that implies limit x tends to 0 minus you're less than this value. This will be the value. So 5x to the power 4. Okay, let me write at the top. This part, I am writing this part. So limit x tends to 0, your f dash x will be this one, if x less than 0. 5x to the power 4 sine 1 by x plus x cubed cos 1 by x plus 10x, and this will be 0 by x, and on the right you will take f dash at this part, x greater than 0, lambda part. So limit x tends to 0, 5x to the power 4, okay, 5x to the power 4 sine 1 by x minus x cubed cos 1 by x plus 2 lambda x minus 0 by x minus 0, x. So that will be limit x tends to 0, 5x cubed sine 1 by x plus x squared cos 1 by x plus 10. If you split and dividing by x, and this should be 5x cubed sine 1 by x minus x squared cos 1 by x plus 2 lambda. So you see this limit is 0, this limit is 0, and on the left you have only 10. This limit is 0 as discussed previous. This limit is 0 and you have 2 lambda. So 2 lambda must be equal to 10 for the existence of double limit. Derivative. Double derivative to exist, you have lambda equal to 5. Lambda equal to 5. This is an integer table. Okay. So next part. Yeah. So next is, this is also the latest question. Next is 15. Let the function f from R to R and g from R to R be defined as if x equals x plus 2, x less than 0, x squared, x greater or equal to 0, and gx is x cubed, x less than 1, 3x minus 2, x greater or equal to 1. Then the number of points in R where if circle G of X is not differentiable, is equal to, let this be also our integer type. So you have composition of functions. So let us first find out the f circle G. This is a very good problem. First, let us find out f G of X, that is f of Gx. F of Gx will be, what is your fx? Yeah, these x are replaced by Gx. So Gx plus 2, Gx less than 0, Gx squared, Gx greater or equal to 0. Okay. Now Gx has two parts, x cube if x less than 1, 3x minus 2 if x greater or equal to 1. So let me replace this. Gx equal to x cube plus 2, x cube less than 0 and x less than 1. I am taking this part. And again this Gx will be replaced by 3x minus 2 plus 2, 3x minus 2 less than 0 and x less than 1. Oh, sorry, x greater or equal to 1. This is x greater or equal to 1. So, okay. Again, this Gx will be replaced by these two values, x cube and 3x minus 2. So x cubed squared, x cube greater or equal to 0 and x less than 1. And the last is 3x minus 2. This Gx will be replaced by 3x minus 2. 3x minus 2 whole square, 3x minus 2 greater or equal to 0 and x greater or equal to 1. So x less than 0 and okay, let me summarize this one. Let me write in a more simplified form now. This is the composition function already. So your f circle Gx is first one x cube plus 2 and x less than 0 and x less than 1. So ultimately this is 1, this is 0, x less than 0 and x less than 1. So the common part is, intersection part is x less than 0. So x less than 0. Fine. This is your 3x and you see this will, if you calculate, x less than 2 by 3 and x greater or equal to 1. So there is no common region, so you have to cancel this part. Okay. And the next part is x to the power 6, x greater than 0 and x less than 1. So 0 less than equal to x less than 1. And the last part is 3x minus 2 whole square, x greater or equal to 1 and x greater or equal to 2 by 3. Greater or equal to 2 by 3, x greater or equal to, so x greater or equal to 1. That's the most simplified form. Okay. So you have 2 points for checking differentiability. Okay. One is 0, another one is 1. So let's test the differentiability. At x equal to 0, left hand derivative at 0. So limit x tends to 0, fx minus f0 over x. So that is equal to, what is your fx? Fx will be x cubed plus 2. Yeah, this one. F0 will be 0. by x. So it doesn't exist because 2 by x doesn't exist. Okay, so it is not differentiable at 0. No need to calculate the right hand derivative. Not differentiable at x equal to 0. Okay, so no need to calculate the right hand derivative. Let us calculate the test at x equal to 1. Left hand derivative at 1. Limit x tends to 1 minus fx minus f1 over x minus 1. So what is your fx? X to the power 6. f1 is 3 minus 1 to 1 and x minus 1, and that will be equal to it's 6. If you apply the standard limit formula, it will be 6. Because what is the standard limit formula? Limit x tends to a x to the power n minus a to the power n over x minus a, that's going to be n a to the power n minus 1. So 6, 1 to the power, so it will be 6. And what is your right hand derivative? Right hand derivative will be limit x tends to 1 plus fx minus f1 over x minus 1. So that is 3x minus 2 whole square minus 1 over x minus 1. So okay, so 3x minus 2 plus 1 into 3x minus 2 minus 1 by x minus 1. So that is equal to that will be equal to 6 also. You check the limit, that will be also equal to 6. So you see left hand derivative equal to right hand derivative. So that means the function is that this composite function is differentiable at 1. So only one point of non-differentiability, that is 0. Only one point of non-differentiability. Okay. So that is how we have solved latest questions. Also, I will solve one question from latest WBJE. Last question of today's session, and that will be the end of our continuity differentiability. Next class will be on trigonometric functions. Just wait. Yeah, I have a latest question paper on WBJE this year, just last week, 2022. Last week it was happened, and this is the question paper, WBJE. So I will solve one question from here. You see, this is the last question, WBJE. The previous questions I have solved, those are from JEE Mains Advanced. Now one question from WBJE. So let fx equal to a0 plus a1 mod x plus a2 mod x squared plus a3 mod x cubed, where a0, a1, a2, a3 are real constants. All are real. Then fx is differentiable at x equal to 0. Your options are whatever be a0, a1, a2, a3. Second option, for no value of a0, a1, a2, a3. Option C, only if a1 equal to 0, and D, only if a1 equal to 0, a3 equal to 0. Okay, I'm just giving you a mean. You have to check left hand derivative equal to right hand derivative. Left hand derivative at 0 will be limit x tends to 0 minus a naught, and you see at 0 the value of the function will be a naught. So minus a1x plus a2x squared minus a3x cubed minus a naught over x minus 0 over x, and your right hand derivative will be, this is left hand, let me write the right hand derivative. Again you have, I'm not writing a naught because this a naught and a naught get cancelled in the right hand derivative also. So I'm just writing a1x plus a2x squared plus a3x cubed, because x tends to 0 plus all will be positive, modulus will be positive, so this is going to be x. So on the left you have minus a1. You see, if you split, it will give you minus a1, this 0, this part limit of the limit will be 0. On the right you have a1. So definitely you have a1 equal to 0. So only if it is only if a1 equal to 0, then the function is differentiable. Okay. So these are the latest question for JEE Mains, Advanced and WP also. Okay. Thank you all of you for today's class. So don't miss the last class. Next class that will be on, I will start inverse trigonometric functions. Thank you all of you.